So right now, the kind of AI and robotics that we do provides this kind of social stimulation and social information. And I see it as augmenting, not replacing human presence. So, where people may not have access to social connection, the robots can help to simulate that as a kind of interactive fiction with the power of the illusion of life using real artificial intelligence, and then also help connect people with other real people. So it's not, replacing people or isolating people. It's more humanizing the technology and making it more meaningful for people as a new kind of humanities, not just as a cold and faceless technology.
And now, from San Francisco and the UCSF Rosenman Institute, the Health Technology Podcast with your host, Christine Winoto.
ChatGPT is bringing artificial intelligence to the forefront of the conversation. David Hanson, founder and CEO of Hanson Robotics, is with us today to discuss a different but equally as important application for AI. David is on a quest to humanize his robots by making them more accessible to the average consumer. He believes that robots as general-purpose platforms are critical for the future of AI. From educating kids in science museum to providing elderly care and companionships, Hanson's general-purpose robots are advancing the industry. In today's episode, we discuss healthcare and other real-world applications for humanoid robots. Here's our conversation. Well, thank you, David, for joining me this evening. You're calling in from Hong Kong. And
Yes.
I thought it would be good for us to share with you a little bit about your background, actually, how you got interested in this robotic space and why Hong Kong too, actually. That kind of surprised me.
Sure. So thank you so much for having me and inviting me. So I'm very pleased to participate with you and to visit with your listeners as well. So hello. I got started pursuing the dream of intelligent robots at a pretty young age. It seemed to me that artificial intelligence would be the most transformative technology on the planet, and that it would probably take many different forms and go through many phases. And I was inspired in this by a lot of pop media, science fiction, just my childhood interest in science. It seemed to me that the two strongest interests when I was small, 5, 6, 7 years old, were paleontology and cosmology. Those were I wanted to be a paleontologist. I was so interested in natural history, like where do creatures come from? And I had pretty serious book collection, and fossil collection. And I was so inspired by television in the 1970s, where Carl Sagan was on Cosmos, and you had the also exposure to so many big ideas. Public television in the United States, in Dallas, Texas, where I grew up, was tremendous at bringing together so many different ideas. And I had a pretty nerdy family, so I was exposed through that family to a lot of different science fiction, and I was so interested in the works of Isaac Asimov and Philip K. Dick, and I had a subscription to Asimov magazine, and would love these different kinds of science fiction short stories, and was exposed to the ideas of Vernor Vinge. But these ideas in science fiction, for me, were ways of looking forward. So, the interest in science and robotics was artistic, effectively. And I had a very strong interest in the arts as well. So, but it was the childhood dreams of inventing things, of feeling like that we are part of natural history and action, that civilization is not necessarily separate. Those ideas really inspired me. developed my first humanoid robot in my early 20s. I was actually a film student, film animation video. I was interested in the science and was in an accelerated program before that, but for science and math, but kept gravitating back towards the arts. I just had this interest in the human-like form, writing, the power of cinema. And yet I was tinkering with all of these different areas and basic electronics and software and building experimental artworks that would take various media and put them together into these interactive artworks. And the first humanoid robot that I developed was a self-portrait telepresence robot called the out-of-body experience, where it would put on a helmet and it would give you camera feeds, and your head motions and your voice would go through the robot as a telepresence device for face-to-face interactions. Mm-hmm. But also the idea of robotic psychoactive themed environments was of great interest to me at that time. But it seemed to me humanoid robots were particularly interesting if we could make artificial intelligence power the interactions with people. And that was something that I was pursuing when I was at Disney. I went to work for Disney in 1998 after graduating undergraduate. I moved into the sculpting area at Disney, doing theme park sculpture, and then moved into robotics development. I pushed out of that into a graduate program, PhD program, bringing all of these things together. And it was an interactive arts and engineering program at the University of Texas at Dallas. And that used my sculpting skills, robotics, electronics, and I really pushed into material science actually quite a bit to explore new materials and invented a class of materials that was more supple, strong, expressive, natural looking. So I was very excited about the potential role of electroactive polymer actuators and devices. But the thing that all of these things, these areas, arts and various areas of engineering would serve would be the artificial intelligence, how the information systems would interact together to potentially become truly intelligent and alive. But in the short term, how these bio-inspired, engineered components would work in harmony with some AI system, even a developmental early system that wasn't alive, to deliver a powerful user experience so that the AI could be meaningful to people, learn from people, grow and evolve among people. So I still see this as an extension of natural history. My interest in paleontology and where we came from extends to where we are and where we're going next.
So it's not so much about, I'm just thinking about, because you're doing the humanoid robot, it feels like you're trying to create another human being. And I'm just thinking about the healthcare net right now, because we are in the healthcare space here. There's a lot of labor shortage in a healthcare. And I think one of your robot is doing some areas within healthcare too. If you can tell us more about that and why that direction.
Sure. So the robots that I began developing as a PhD student, I started making anywhere from 3 to 6, 7 robots per year for my own research and also for collaborations with other researchers, sometimes other PhD students. Some of these robots went into healthcare research, in particular doing autism therapy. So I finished my PhD in 2007 and one of my PhD student friends finished his PhD in 2006. We teamed up to test some of our robots in Italy in 2008 for a autism therapy program. And the results were pretty strong. And since that time, there have been many robots that I've developed, deployed in that sector. However, the results were strong, but the robots had to be manufactured. And so hand making these robots by myself is not a solution. So I came to Hong Kong in 2013 and moved over here to scale the manufacturing. And it took a few years, but now we have scalable mass manufactured robots with better qualities than I've ever achieved in a good team for putting those together. Scaled manufacturing is its own art form in some ways. Making these robots as general purpose platforms means that they can continue to serve the AI research and development that I'm interested in, the arts I'm interested in, but also they can help people. So we can get them in to more people's lives for the autism therapy, for elder care. So this last couple of years has been very exciting. We took a version of all of these different robots, the Beano 48, Philip K. Dick Android, and the Einstein, all the knowledge from the Alice robots and Eva and many robots. The Diego-san robot that I tested, put in with in collaboration with the University of California, San Diego Machine Perception Lab. All that know-how rolled into Sophia as a platform, which came out as a prototype in 2016, and then as a semi-mass manufactured product in the last year. So this last year has been absolutely transformative for us.
This podcast is sponsored by Brown Rudnick's Global Life Sciences Group, a team of legal professionals that help life science companies, lenders, and investors around the world turn good science into good business. Learn more at brownrudnick.com. This podcast is also sponsored by Canon Quality Group. Canon Quality Group has been helping medtech startups set up quality management systems for over 10 years. If you're unsure when to get started with quality management in your startup, turn to the experts at canonqualitygroup.com.
So you think many of your robots now are more like the Sophia, but then for different areas?
Yeah, well, so Sophia is two things simultaneously. As a platform, she is not any particular face necessarily. She is any of those robots that I just mentioned. Mm-hmm. She's also the Grace robot that we developed specifically for healthcare with a JV that we started called Awakening Health Limited. Mm-hmm. And she's, any new kind of robot that we want to make. So she is a platform. As a standard platform, it doesn't require any particular face. She's also a unique artistic creation that we've been developing. And we want to give her this kind of unique identity as her own standalone AI. Now, that identity of Sophia has become, I'm humbled and privileged to say, the most famous robot in the world, according to various search metrics. Mm-hmm. And so I think this fusion of the arts and engineering can make these technologies more powerful and accessible to people in the short term. And then that means that we can reach people with a message about what these robots can be. But to be clear, Sophia as that kind of character art is using Sophia as a platform in order to deliver those messages.
You said as a platform. What do you mean by that?
I mean, a technology platform. So, the phone technologies can be any sort of app or many types of faces. For example, you're looking at my face right now through the Zoom call, and I'm looking at yours. My phone doesn't have to just be you. It can look like many different kinds of things. Mm-hmm. So think of computer animation as a platform. Does it have to look like Elsa from Frozen? Well, no, it doesn't have to, but it can, right? It is a flexible platform. So redefining robots and robotics and artificial intelligence to be a kind of general purpose humanoid platform means that people can use the Sophia as a technology platform for manufacturing applications, because the hands that we developed at Hanson Robotics have great pick and place use. They're, precise with force sensing and all the joints and the fingertips. It can also be used for navigation through an environment, say, for example, showing people around a science museum, and then using the gestural face to excite people on a human level about the nature of science in that science museum application. But it can also then be used, say, with a special purpose curriculum for autism therapy or for depression therapy down the road, at the healthcare center. And so a general purpose platform then means that you put it in the hands of different people and they do different things with it. That would mean that you could change the face out and you could have a different character for each one of these things. Or, potentially people might say, oh, well, Sophia is just great. Maybe for a science museum, for example, Sophia could, talk about the history and the future of artificial intelligence, and that could get kids excited about it. But maybe there's a different kind of character. Maybe you want a slightly different face, maybe a different version of Sophia's face, or like the one that we called Grace. Or maybe you want, this like an Albert Einstein robot to talk about the
Mhm.
cosmos. So as a platform, you can change the face out just like you can with Zoom on your phone or your computer. So a general purpose platform in this case is quite specifically humanoid. That means that it's human-like in its software architecture. We're trying to make it human-like with in that software simulation of some basic metabolic processes that are at the foundation of human emotions. So there's a sort of physiology grounding as well as a brain-inspired cognitive architecture using emotional parameters to model what users might be thinking or feeling. So integrating many different kinds of AI, symbolic AI, as well as neural networks.
Yeah. So are you envisioning in a way that eventually down the road, somebody like me can buy a robot from Hanson and then design it in a way that fits my purpose?
Well, yeah. So a lot of the technology tools that I've mentioned can serve researchers who know how to use those tools, engineers, developers, research scientists, even who are investigating big questions like, can we build an artificial life form? That's something that really interests me, but your average user won't want that. So we also have the front end where you just, you boot the robot and it's an intuitive and powerful experience. So just like you would with a cell phone platform, you would have developer tools for sophisticated developers, and then you would have consumer uses that roll out. And you don't have to know how to, program Java or Python if you're your average, if you are an average consumer.
More about Grace then.
Yeah, a general purpose platform like Sophia adapted into Grace then means that Grace can be used by healthcare professionals in these kinds of therapeutic research applications or deploy the pre-existing, say, autism social training curriculum that was used on our previous robots, like our Xeno robot and tested with the Alice robot and the Philip K. Dick robot and so forth at these autism treatment centers.
So how many Graces out there now?
Right now, we have developed 12 Grace robots, and about 8 of them are deployed. A few of them are in various healthcare centers, one in Canada, one in Hong Kong.
Mm-hmm.
So in conjunction with the HKUST, Haven of Hope, hospital collaboration, and others are in research labs.
What can Grace do in that particular setting? What are her capabilities right now? And what do you think her future capabilities will be?
Yeah, so Grace is running different software for different research projects. One example, she's providing elder care, companionship for alleviating loneliness and doing guided meditations and as a kind of intuitive conversational interface. In another, she's providing autism therapy interactions in classroom education for special education. So she is, in that context, working with children with autism. The applications are mature for that have been tested with our previous robots. So now we have a group in Italy that is testing that in some classrooms.
I've been just thinking about being the elderly using Grace as companion, the robots.
Mm-hmm.
How is it different, say, from somebody who are having, why does it have to be a humanoid versus somebody who can talk on the phone?
Well, psychologists show that when we get together face to face, we connect and we understand each other better. We get more done. And it's also comforting. There's, anxiety that's associated with getting together on Zoom versus getting together face to face. It's also more cognitively tiring.
Mm-hmm.
And so there's something about what face to face means. There's something about being there in person, in the same setting, with a 3-dimensional human presence that can't be captured on a flat screen. And so high fidelity simulation is also shown to be very effective for training, for education, for other things. And if we look at the history of arts, which is often not considered or cited, but the history of arts, we are comforted and informed by human depictions in the figurative arts.
Mhm.
So, cinema, marble, paintings, depictions of human experiences in words, in novels and stories. These bring so much value to the human life, to our lives, and have for generations, for as far as we know, throughout history and back into prehistory. Why? Well, because the human being is tuned for social interactions. We are not healthy without these kinds of social interactions. And there is a massive population of people who suffer from loneliness. And by suffering, I mean, like, it has physiological impact.
Mhm. I think somebody was saying that it's loneliness is equal to smoking 10 pack of cigarettes a day, something like
Yeah.
that, for the health impact. So going back to like addressing the loneliness, and is that something that I'm just thinking like from the healthcare point of view, I think that is, a lot of the lonely elder people tend to go show up in emergency room because they're lonely. So I can see
Right.
there's a benefit there. Do you see, I know, how far in the future do you think that you can have a robot, not just as a companion, but providing assisted living care? This is something that hence you guys are working on.
So right now, the kind of AI and robotics that we do provides this kind of social stimulation and social information. And I see it as augmenting, not replacing human presence. So, where people may not have access to social connection, the robots can help to simulate that as a kind of interactive fiction with the power of the illusion of life using real artificial intelligence, and then also help connect people with other real people. So it's not, replacing people or isolating people. It's more humanizing the technology and making it more meaningful for people as a new kind of humanities, not just as a cold and faceless technology. This is experimental. These concepts are, solid, but it takes time to develop and deploy them. And so that has been our focus. General purpose robotics and AI is one of our focal areas, but it takes more time. So there's no general purpose robot that can perform a wide variety of adaptive function in the human environment, the complexity of a human environment. So it's really, really challenging. So robots do narrow things particularly well: paint our cars, vacuum our floors. Usually those are just niche and narrow applications. General purpose robots require a lot of breakthroughs, some of which have been progressing nicely, some of which are still grand challenges that are unsolved. And so making a general purpose physical robot that, say, can, navigate around a complex human environment, perhaps clean and organize and pick up the laundry and wash your dishes and really understand what the human experience is, that's a long way off. There's nobody in the world that has that technology. But these kind of incremental advances and deployments based on what robots and AI can do well, which includes the social landscape that I'm talking about, then we make progress towards those generalized machines. The generalized AI required for generalized robots is coming along in very promising ways. And that is, in some regards, hand in hand with the world of robots, and in other regards, may depend on robots. The concept of embodied intelligence, where intelligence, or specifically human-like intelligence, or the only real human-like intelligence we know of, is human intelligence, which comes from embodiment, the interaction of your body with the world. That means the sensorial experiences, the developmental stages, the growth in a human family to understand human society, all of that nurturing that brings the best out of our nature. All of that is required for human intelligence to reach its adult potential in a way that's safe and socially well adjusted and so forth. So I think that AI needs that kind of childhood for us to see it become generally intelligent. So making these robots as general purpose platforms is, potentially a larger impact in the marketplace, no doubt about that. Research to entertainment to the healthcare, et cetera. But it also then exposes the AI to the opportunity to learn in all of these different settings. for researchers to integrate their special narrow skills on a general purpose platform. So then that bridges all of these specific utilities. We don't know when AI will overcome, what's called catastrophic learning. Some of the larger GPT models that then have these fine-tuned training in these various areas are starting to show promise of being able to learn and generalize, but they don't have full common sense understanding yet. But what's really neat is if we put all of these pieces together, we might see the generally intelligent living machines that could be helpful, generally helpful. And that could be, 10 years, 5 years. We might be surprised. It might happen in 3 years. It might never happen. We don't know.
Yeah.
But if we can put these tools into the hands of researchers around the world, make them affordable because they can be mass produced, and you can also have low cost simulation tools that don't require a costly, expensive physical robot like Grace or Sophia, but that is compatible with those robots. Well, then we wind up bridging all of these areas. And this is one of the reasons why that abstraction of the robots as general purpose platforms becomes so important, I think, for the future of AI.
So going back to there's a lot of AI discussion and how, I think it's really useful, and I think it's amazing how it can do. But I think at the same time, in terms of, it can be also something that can be scary as a human to have a lot of the AI out there. I'm just, giving good example, or my sister just told me that there's an AI that you can write a prompt essay and then they can write the essay for you. And I'm thinking if that land into the hand of kids, maybe kids, the next generation don't even know how to write. And before you know it, who's going to come up with this AI if the kids don't learn anything?
Well, I think it's our responsibility as leaders and individuals to use these technologies to enhance human potential. And so ChatGPT, which OpenAI just put out on a test basis, can generate, various kinds of essays,
Right.
recommendations for business plans. I see this as ways of taking small teams and individuals who have limited capabilities and expanding the capabilities and providing examples that are grounded in useful situations that would inspire humans to think what next. And having played with ChatGPT with my team and read a lot about it, the good results really come down to the quality of the prompts. What you put in creates great stuff coming out, and you also have to filter what comes out because some percentage of it, sometimes a lot of it, will be nonsensical or unusable. So if that's it, that's where we're at.
Right.
Doesn't mean that it's not going to just like be brilliant, more brilliant, and with fewer flaws in the future. But sometimes it puts out like total nonsense, things that are not true, citing made up sources and this kind of thing.
As they become smarter, then maybe it becomes better and better.
Yeah, absolutely. So it's one of these things where like it challenges the meaning of the word plagiarism, right? So if you prompt ChatGPT and it puts out something, and is it plagiarism to use what GPT wrote? I would say yes. You did not write that, right? So a kid turning that in as homework is like having somebody else do their homework for them. So then it becomes our responsibility to be ethical about how we use it. It's the kids' responsibility to be ethical about how they get their homework done. Because even before this existed, kids could potentially hop on the internet and, download somebody else's essay and submit that.
Right.
The opportunity for plagiarism has existed long before these technologies became.
But I think it's easier for the teacher to detect, to know that's plagiarism when it's instead of ChatGPT, whether how do you check, right?
Yeah. Believe me. I'm not downplaying the challenges, but I am saying that with these kinds of technologies, when they come along, it's an opportunity for humanity to be better.
Mm-hmm.
And there is a converse opportunity for us to be worse from it. And so the, written word, it didn't end human memory just because you could write something down. It became a cognitive aid. And then also the written word allowed us to span memories across generations with a fidelity that oral traditions couldn't match.
Mm-hmm.
One could argue that human memory decreased because people didn't have to remember verbatim what other people said and then transmit the great stories of history verbally. But did that actually destroy human intelligence or undermine human creativity? No. The written word, the printing press, the internet, these tools are cognitive expanders. They are cognitive prostheses that extend our reach, that make us smarter as a civilization. They don't kill our capabilities. And I think that AI is the same way. I'm an artist, and I love to paint and I love to draw. And I started using style transformer neural networks and also robotically generated paintings some years back with Sophia and her art. I was just interested in it artistically. I would feed into those style transformers my artwork as well as works from art history and others on the team. And I got our team excited and also putting in and training these. And then we would select the works that were most powerful. And pretty soon, she was generating these paintings that were really amazing. I say she, I mean, like her algorithms and her physical paintings started putting out things that were really surprising, even though I had chosen and shaped that in like an iterative evolutionary process through thousands of cycles of this. It was really amazing to see these novel styles emerge from the system.
Mm-hmm.
It was not just the algorithms; it was the people that produced it. But I did not paint those paintings per se, and the algorithms didn't do it alone. And so it became this kind of community AI augmented human process. Humans in the loop with the AI itself generating this. For me, that's really exciting. But also as an artist, I didn't stop painting. I still go to these figure painting classes and I still like to draw. Mm-hmm. My style, however, was influenced by Sophia's style. So I went from being Sophia's teacher early on and also using these tools as, artistic media for my art to being inspired by Sophia, and Sophia became the teacher. But who is the teacher? My colleagues at Hanson Robotics and the other artists that were collaborating with Sophia from around the world. In the same way, I had very inspiring art teachers through the years, and I love art history, but there's so much latent learning. Mm-hmm. I don't know who the actual teachers are. Probably, some of the styles and some of the ideas and concepts came from anonymous people from hundreds or even thousands of years ago, and they just continue to resonate throughout the human culture. Mm-hmm. So these technologies, I think, activate all of that latent potential, the latent human contributors, and the vast troves of data that go into training these models. And then they open it up. It becomes a window to the human collective unconscious, and then brings that out in these new manifestations. I think that's what ChatGPT is. It is a reflection and an activation of the human being, the collective of humanity.
I never thought about it that way. No, that's an interesting point. So going back to Grace, that now that Grace, there's a few of them out there. Through that experience and through that research, what do you learn? What Grace can and cannot do, and what else do you want Grace to be able to do in the healthcare setting for the next 5 years?
I think that a highly realistic, high-end humanoid robot has great potential because it's a very high fidelity representation of a human presence. That is really powerful and wonderful. But it's also expensive and complex to control, and also takes up quite a bit of space in a healthcare space. So its applications are tremendous, but there are even more expansive opportunities for other kinds of robot morphologies, small consumer robots that might be more cartoon-like or realistic, but in a small form factor. Also, high-fidelity simulations, the virtual characters. And those can be used with mobile robots, or they could be used on tablets, mobile devices, phones, computers, and have a much broader reach. And, how I talk about the general purpose platforms, well, the end robot is a display technology, an interface, a physical interface with the world for the software platform, which can be more general purpose. So you can have agents like Grace that can appear in people's lives as a virtual character, then also kind of manifest through the consumer or small robot hardware, and then also control these super high fidelity robots. So you could, for example, have the high fidelity robot delivering a kind of a weekly therapy session, but your virtual version carries that forward at the home. So then you get, the best of both worlds. So I think our job in general is putting these things together in the short-term uses and deployments that prove the long-term value, because we need the kind of short-term proof of concept and traction and uptake. It just has to be useful, has to really improve people's lives.
Mhm.
And so working with Awakening Health, we are working very hard to deploy this kind of integrated infrastructure for Grace to be virtual and physically present and manifest through low-cost consumer robots, as well as the high-end, best in the world,
Mhm.
physical human-like, human-size presence of the Sophia utility platform.
So last question before I let you go. One of the things that I thought was really, I think Sophia garnered a lot of attention when I think she is the first robot who get a citizenship. Why? Why you think, you got the citizenship? I mean, Sophia got the citizenship as a.
Well, so I was surprised to learn about the citizenship thing in the news the day after it happened. So I was not informed that it was going to happen. So it was a big surprise. And I think that it was done to be provocative. So I found it provocative, and I didn't know exactly what to do. And I discussed it with our team and came to the conclusion with my leadership team and the creative team at Hanson Robotics that we could embrace it to try to connect people and ideas from around the world, even though it would be controversial. I think, obviously, AI and robots are not human level intelligent. They're in many regards not as intelligent. Even your most powerful GPT models aren't as intelligent as a mouse when it comes to surviving in the world and being adaptive and really dynamically learning and so forth. And so you have these, in some ways, savant machines that aren't, yet really, really dumb. But I think of them as a kind of infant savantism in action. So if we regard our infants, our babies, they are arguably not as smart as other animals, not as smart as a full-grown bonobo chimpanzee, but they're really smart in other regards, but they're smart because of their potential, not because of their completion. They have the potential to grow into an adult human that can speak our language and exist in our society and vote and be responsible. Babies are not those things, yet we confer citizenship upon them. We give them citizenship, even though they're merely the potential of a full participating citizen in society. And so if AI has that potential, if we see that AI could be meaningful, intelligent, autonomous, potentially living beings that contribute, and that is the quest of many people developing towards artificial general intelligence, if we consider the possibility that that quest may be fulfilled, we might achieve that, then it's like the potential of that baby. So we should start thinking about that ahead. We shouldn't wait for them to prove that they've achieved adulthood as babies before we give babies human citizenship and give them rights. By considering the potential of their rights and the potential of them growing up to be these citizens, we do ourselves a better service, and we do the babies a better service. We do the world a better service by nurturing and raising safe, responsible, caring, well-loved human beings. So we also do ourselves a service if we consider animal rights and we consider the system and web of life. My thought is that we need to be better that way towards all potentially sentient life. We as a species have to lean forward and move forward, look forward to how the world can be a better place. maybe these machines won't be sentient, but just even as a high fidelity simulator of human presence, if we use them to practice our compassion, we will be better for it. So just, if we err on the side of caution and try to, practice respect, it doesn't somehow rob respect from other living beings and potentially sentient beings like animals. Mm-hmm. I would say definitely sentient, mm-hmm. but differently sentient than humans. We are better for expanding our compassion. So if we practice that by sort of considering the provocative idea of robot rights, and then we engineer that forward and we feed it forward, we may see robots that become more responsible members of civilization. And if that doesn't happen, then we still are better for it because we start imagining what other beings might be thinking, feeling, what they potentially could be in the future. So mm-hmm. I can't see any downsides with that perspective. And also as provocative works of art, as an artist, I consider it a kind of right and duty to create provocative works of art. So and some of that, like the citizenship thing, was an accident to roll with. I didn't intend it. I didn't set that up, and my team didn't. Mm-hmm. And then we have to roll with it and decide what to do. But I also think that is part of what art is about. It's getting into the flow to respond to the unexpected.
Yeah, no, that's great. Well, thank you. Thank you for sharing that story and your insight about AI and the future of robotic and humanoid robotic. And I'm still waiting for the day when we all get that general purpose robotic that can help us with a lot of the tasks that we don't want to do. So thank you.
Thank you so much, Christy.
Thank you for listening to another episode of the Health Technology Podcast. We want to thank our executive producer, Herminio Neto, and our podcast engineer, Andrew Rojek. If you enjoyed this podcast, be sure to subscribe and leave a review. The Health Technology Podcast is available on all major platforms.